Hi friends. My guest this week is Professor Brian Keating, and he almost won the Nobel Prize. And today we're going to find out just what it feels like to lose it. It's a really cool story. He set up the Bicep 2 telescope in Antarctica, and it looked like him and his colleagues had made a unique discovery, and there was a roller coaster of what actually happened and some disputes about the data and what it showed. There's politics from the Nobel Prize Association, and I didn't understand what it was or how it works, how it's chosen, and what the process is and the heritage of this particular organization are. But we're going to find all of that out today. It's a very interesting story, albeit at the expense of Professor Keating. But if you enjoyed this episode, go back and check out the ones with Sabine Hossenfelder and Professor Adam Frank. They're both fantastic physicists, and they have a lot to add to this discussion about the politics of science. Obviously, if you love the episode, please share it. It makes me very happy. But for now, let's welcome Professor Keating. Oh yeah, P.S. I've started to shorten down the intros to these podcasts because I respect your time, and I found myself skipping through a lot of the introductions to podcasts that I listen to as well. In future, I'm going to endeavour to keep them around about 1 minute. I think this should be enough time to tell you about the guest and inform you of any upcoming announcements which are important. But if you feel like you need to know more, or less, if you want me to chop it down even further and just say hi friends, then let me know at ChrisWillX on all social media. Professor Brian Keating, how are you today?
I'm fantastic, Chris. Thanks for having me on.
It's an absolute pleasure. So, what are we going to learn about today?
Well, I kind of sought out your podcast, so I don't know how usual that is, but I heard my friend Mario Livio on your show about 2 months ago, a month and a half ago, and the interview that you did was phenomenal, and of course he's such an engaging and erudite fellow that I felt like it would be a good opportunity for me to share some of the ideas that I've been thinking about in my work as a cosmologist. As I point out, I don't do hair and nails, but I am a
cosmetologist.
Although a lot of people think I do until they meet me. Nor do I tell horoscopes, but instead what I look for is really the earliest evidence for the beginning of the universe. And what I thought is so interesting about the perspective that colleagues such as myself can provide in contradistinction to those of, these erudite, brilliant folks you've had on like Mario, is that I'm an experimentalist. So an experimentalist as a cosmologist, it doesn't mean that we build universes. I've got a healthy ego, but not quite that healthy, to think that I could actually build a universe. But instead, we build telescopes that will allow us, hopefully, to reveal the earliest evidence for what's known as the Big Bang and how we came to know what the universe is comprised of along the way may hopefully be revealed through the types of telescopes that myself and my colleagues built. And this is very different from those of the professions, as practiced by your late countryman and my distant late colleague, Stephen Hawking, or Sir Roger Penrose, who recently visited me in San Diego and was part of our podcast that we run for the Arthur C. Clarke Center here in San Diego. And that is, to study the universe from a purely theoretical point of view is absolutely necessary. And I always say, some of my best friends are theoretical physicists, but in reality, we have learned much more about the universe from people that build instruments, whether it be Galileo or Newton, or people that are connected deeply to instrumentation, because there are very few theories in the world. If you think about it, philosophically, there can only be so many different descriptions of how the actual world works, many fewer than how possible worlds could work. And I'll give you one example, and maybe we'll talk about that at greater length today. For those in the audience who may have heard of something called the multiverse, this is a very controversial subject within physics and even philosophy, and it really revolves around the notion of whether our universe is alone, whether ours is the only universe, both that exists now or may have ever existed or will ever exist in a distant future. And that's quite an astounding thing to think about. It's motivated in some sense from the thought of people like Copernicus and Galileo, who showed the Earth is just but one of many planets in the solar system. Now we know there's but one of the Milky Way is but one of many galaxies in the universe. So perhaps it's natural to think maybe we're not just the only universe in what's called the multiverse. So these are the kind of things we study, but in contrast to many other, kind of more popular, maybe much smarter, better speakers than I am, but these folks that study things from a purely theoretical perspective. It's just a different perspective. I thought it would be great for your audience to get a taste of.
I couldn't agree more. How different or how bipartisan is the world of physics when it comes to the experimentalists versus the theoreticalists?
Yeah, the theoreticians. That's right. Yeah,
theoreticians. Wow.
Yeah.
Nice.
It's kind of like, Republicans and Democrats.
Is that really what it's like?
Tories and we never talk to each other. No, it's much healthier than that. I would say it's like it's much less of a rivalry than any sports team.
Is it like the offensive team and the defensive team of American football?
Yeah, except I wouldn't want to wager on the theoreticians I know to be very good footballers. But anyway, you'll edit that out, I'm sure.
I think that I think Mario. I wouldn't back going up against Mario Livio. He seems like he's probably got a bit of a vicious streak to him when he needs to get going.
He's got a massive side. That's right.
Yeah.
Indeed, yeah. There is I would say a healthy rivalry, as there should be. So it used to be. I don't know how it is in the UK, whether you're football teams there, but in America, there used to be laws, in unofficial laws within sports teams for our version of football, that if you were playing against an opposing team in American football, you weren't allowed to socialize with them the night before the game. Like they're called anti-fraternization laws. Like, well, that's not really very friendly. That's not very gentlemanly. Yeah. But of course, our version of football. Yeah, we wear helmets, and you guys in rugby and football don't do anything. We're kind of, different that way. But there was a rivalry, and you want to stoke that competition and those juices, because it was thought that competition would be compromised if they were too friendly. And I just contrast that to the word fraternization means fraternal. I have 3 brothers of my own, and I don't think we'd ever characterize our relationship, as very, friendly in a competition, even a physical one. So perhaps that's misnamed, but I think there should be a skepticism. It's very easy to write papers and conjecture marvelous things like wormholes and extra dimensions and the multiverse and things like that. It's easy in some sense. Of course, intellectually, it's very challenging to actually be able to back that up. But it's sort of when there's no skin in the game, as Nicholas Taleb says. There's nothing really. They're not going to go out there and build the experiment to detect it, and that's very different than the way things used to be. Right? Galileo would have an idea that falling masses, decelerate or accelerate towards the Earth at the same rate, regardless of their mass or composition, and he showed that, and he built an apparatus, allegedly the Leaning Tower of Pisa, etc. But he did other things that we know are not apocryphal. Newton built telescopes, and he built other apparatus. He was, of course, an alchemist, and he was actually involved in the day-to-day events of the world. But and even Einstein had patents, which is quite amazing to think about. And of course, the great physicists of the 20th and 21st century, many of them, had equal facility with experiment and theory. And I think that's the nature of a well-rounded Renaissance man or woman physicist, that we should aspire to be capable of forays into both the purely abstruse theoretical domain and what it actually takes to have skin in the game to go out and measure it. And
I get that completely. Is it it seems like the sky's the limit, really. Oh, actually, no, because that's probably a poor term to use in your field of work, right? But the something is the limit for theoretical physicists. As you've said, they can if they can postulate it and back it up with an existing theory, which again can also be based on something which hasn't been shown to be true in experiment, but perhaps makes sense mathematically given the constants that we know about the universe, etc., that they can say it and put it forward, and downstream from that, there's actually no real implications other than, oh wow, you wrote a really cool theory about this particular thing. Let's run with it and see if anyone else fancies backing it up.
That's right. Yeah, exactly. So it's I kind of view, and this maybe your listeners and maybe you'll appreciate the analogy. It's kind of like I feel we as experimentalists are the bouncers in the nightclub of the universe, and that we actually are the ones that squash and keep things out and keep the field honest in a sense. And it can also happen to us, as I describe in my book. So my book is called Losing the Nobel Prize, and it's a story. It's really kind of like the dirty laundry or confidential, kind of tell-all about what it's like to be a professional scientist in this current era. And that also means that sometimes you get swept up in sort of the pursuit of things that are non-scientific in nature, in that they may be related to benefiting your career or your pocketbook or what have you. And this is a relatively new affliction. I don't think very many people in the olden days were concerned as much about fame and fortune in science. And it's certainly true that, Einstein didn't die a billionaire, right? I mean, his ideas in some sense were responsible for a lot of the technology from GPS to the laser, and he made some money, but he wasn't born. But if you look at how much he could have contributed intellectually versus monetarily, it's vastly outweighed. So I think that it's important, as I say in my book, we can write a book about the multiverse or the wormhole or the black hole, but you can't really put it on the cover of the book, whereas every single book comes with a dust jacket, right? And what does it do? It's keep dust out. I mean, I always hated dust jackets, and I always thought they were useless and they'd get in the way of the book. But now I realize that they serve this vital purpose, which is to keep the dust out of the story. And the story in my case is intricately dependent on the role that dust in the cosmos, in this case, plays. And so I say to my friend, try getting a wormhole jacket on the cover, and I'll be very impressed.
I get that. So, Losing the Nobel Prize, tell us, where does the book begin? What's the story?
So it's really a three-part story. One part is a memoir of what it's like to be a cosmologist, to work with some of the biggest minds, intellects, and egos in the world at the cutting edge of astronomical discovery. In this case, we built the telescope that we put at the very bottom of the world at a location called the South Pole, which is the sort of central part of the Antarctic continent, reached for the second time in 1912 by one of your countrymen, Robert Falcon Scott. He famously arrived there just 3 weeks later than his Norwegian counterpart, Roald Amundsen. And that 3-week delay ended up costing him and 5 of his employees, if you will, their lives. And I draw some parallels between the quest to conquer Antarctica and the South Pole in particular, and the quest to be the first in science to make a discovery that is as important, as is foundational, and as is important career-wise to its discoverers as the finding of the South Pole was, or the landing on the moon in the 1960s was for America. So that's part one. What it's like to be a scientist at the bleeding edge of competition, collaboration, and in some cases controversy.
Is there not very many bits of low-hanging fruit? You've said it's kind of like a winner-take-all competition here, and if you want to be the first person to reach a pole in the world, you've only got 2 choices, right? Like that's it. Once one's gone, there's only one left, and once that one's gone, you're fucked. So is it similarly, is it kind of needles in a haystack, so to speak, in terms of finding like the big winners?
Well, there's a famous quote by John Archibald Wheeler, who was, Feynman, one of Feynman's advisors and so forth. But that was, our job is to expand the island of knowledge into the sea of ignorance, something to that effect. But when you make an island bigger, you're also making the coastline between the border between ignorance and knowledge bigger and elongated as well. So I think that's sort of the job there. It's harder and harder to find new frontiers. That's certainly true, but there's so many mysteries. There's so many things that are just staring us right in the face that we know nothing about, that some have decried the stagnation in cosmology and physics in particular, and really this glorification of the past as a symptom of the relative backwater stagnation that's occurring within physics today. Namely that there haven't been, according to a German physicist, Sabine Hassenfelder, make a good guess someday for you as well.
I've already had her on.
Oh, you have? Okay, great.
I've already had her on. Yeah, I was going to ask whether or not you'd heard it, but yeah, we had a discussion. I was going to mention some of that with you as well. So we'll get into that in a second. What was what was the quote that you had from her?
Well, it's really just the claim from her that there haven't been any developments in nearly 50 years that rival the developments of, say, the preceding 50 years in physics. And that is, kind of depressing on one hand. But I note that she's a theoretician. She's not an experimentalist. And that's why I think it's so exciting to be someone who can build, interact, and acquire data from these sentinels, whether they be located underground, in space, at the South Pole, in the Atacama Desert in Chile. And I think it's the most exciting time in history from that perspective. So I don't disagree with her that, she may have chosen poorly in her field choice. We have a friendly kind of rivalry.
She's awesome. I love Sabine.
Yeah, she's a certain contrarian. And so what I really feel is that it couldn't be more stark, the contrast and the kind of ebullience and excitement that I feel every day getting to do what I do, versus kind of the depression and sullenness that I see from my theoretical colleagues. So I'm always trying to convert them, get them out of there,
across the aisle.
Yeah, exactly. Get them on the other side of the team.
I love it. So what's part two?
Part two is really a story of how we came to know what we know about cosmology. So a history of the universe from the first telescope ever used in astronomy by Galileo up through the Bicep 2 telescope, which is a telescope that I conceived of and helped to build at the South Pole, Antarctica, that seemed to provide evidence for what was claimed to be the biggest discovery of all time the day we made the announcement, and certain to rack up numerous Nobel Prizes for those of us potentially who built the instrument, and certainly for the theoreticians who made the predictions. And how did the inflationary universe that I described, how did that come to be, and what are its implications? As I said, the multiverse is a natural extension. It's a consequence, according to the founders of inflation. Without the inflationary universe, being true, there would be no multiverse, and only if there is inflation can there be a multiverse in many of these theories. So it's incredibly high stakes for cosmology and for philosophy and all of physics that we get this right. And our experiment claimed evidence for this back in 2014 to global headlines and fanfare, Nobel Prize whispers. We later had to retract that statement, that claim, and what that experience was like as a physicist and as a human being. I think, when you interview these brilliant people, I think the layperson is most interested in what are they like as a person? Like, what was Einstein like as a father? That's something that's always interested me. Like, what was, Feynman like as a friend? Those are more interesting. Like, I can learn the physics. The physics is sort of immutable. It's like, it's possible to learn the physics without knowing the personality behind it. But that's why these biographies of Einstein and Feynman that keep coming out. It's like, how many biographies can you have? It's like, did he have a secret double clone somewhere?
I think if anyone was going to have a double or triple or quadruple life, it would be Richard Feynman.
That's true.
The discussion I had with Mario Livio, I think as close as Mario Livio can have a man crush on someone, I think Richard Feynman just about might be it. What's super interesting you said there, talking as a perfect representative of the layperson when it comes to physics. I hadn't taken a massive interest in Isaac Newton until I found out about all of his very strange quirks and beliefs and how he used to love to go to hangings, and he kind of had a little bit of a sadistic side to him, and he spent more than half his career trying to prove a bunch of theological stuff to be true. Right. And I'm like, fuck gravity. Like, I want to know about like his weird quirks and
right.
Do you know, like that? It humanizes them. You're totally right.
Did you never hear what he claimed as his greatest accomplishment for the man who came up with calculus, the law of universal gravitation?
Lay it on us.
that he died a virgin. That I remember hearing that he claimed was his grace because it was as close as he could get to emulating Jesus Christ. And it shows you the esteem with which he held. Now, I'm not for, deconstructing just to tear somebody down, like, oh, George Washington wasn't great because he had slaves. No, although I do kind of deconstruct the Nobel institution in the book, and that's the third part of the book.
Yeah.
As what does it mean? Because what ended up happening was I was, we made this announcement. I'd kind of been edged out in a dramatic series of events from the, basically denied the paternity of the experiment that I helped to sire.
So let's just roll back a tiny little bit. So we've got the BICEP 2 telescope. First off, why is it called the BICEP telescope? Why is it a BICEP at all?
So the inflationary universe predicts that if inflation took place, the universe would be suffused with what's known as gravitational waves. These are waves of the gravitational force field. So as they pass by a person, say, if that was possible to imagine, the person would gain and lose weight alternatively as the wave propagates by. So it changed the force in which gravity is pulling on you. Obviously on Earth, it wouldn't make any big difference, but say far in interstellar space, and potentially this is a thought experiment you could do. Now, you know that these gravitational waves were first detected directly in 2015, resulting in the LIGO experiment leadership, or at least 3 of the 4 people that did it, and winning the Nobel Prize, which is a problem that we can talk about. And then that was for the coalescence of 2 black holes of a mass, each one about 30 times the mass of the sun. They came together and made a black hole that was slightly less massive than a black hole with the mass of 59 solar masses, say. So one entire mass was converted to gravitational energy. It couldn't be converted to light. These black holes, by virtue of their intense gravity, are black. And so they coalesced. They gave off, by Einstein's equation, E equals mc squared, they converted 1 solar mass worth of mass, their gravitational binding energy, into pure gravitational wave energy. That, if you can imagine, all the mass in the universe, not just 30 solar mass black holes, every black hole, every galaxy, every person, every single planet, everything in the universe exploding forth, not just over the course of a second as these black holes coalesced, but over the course of a trillionth of a trillionth of a trillionth of a second. How violent that process would be. That would create waves of gravitational energy. Those waves would travel at the speed of light, and they would influence the oldest light that we know to exist in the universe, and that's called the cosmic microwave background radiation. It's a type of microwave energy, radio energy, that comes to us in all directions. That energy would be twisted and curled in a certain way that I describe in the book, with about 60 illustrations custom made for the book. And that twisting curling pattern was known as B-mode polarization, or curl pattern polarization. And so when I made up the acronym BICEP, I wanted to reflect that we're trying to muscle our way back to the beginning of time and get the jump on these curls. So the bicep does the curling on your body, and so that's the origin of the name.
That's such a good name. That's a very clever way to do it, and there's gym bros up and down the country that are applauding you for coming up with it as well. So we've got the telescope. I'm going to imagine it must have been an absolutely massive undertaking to be able to come up with something like that, and it's in the most inhospitable climate on the planet, that is the most remote, with the least supplies and all the rest of it. So what was the process like of actually creating it?
So creating it, I always say, was less difficult than actually, like coming up with the idea was harder than actually building the thing. Because sorry for interrupting. Is that a reflection of the theoretical versus experimental debate again? Do we think? Yeah, exactly. So
very figurative, eh?
Yeah, it's very hard to convince other people what a great genius you are, So, but it turns out you need to, in order to have the wherewithal, financial, and the most valuable capital, human capital, and getting young people to believe in your ideas and to follow you literally to the ends of the earth, as they did. And then to actually build the instrument, is an engineering challenge, but it's not an insurmountable one. Now, I say so with a little bit of glibness, but in truth, I have to give credit to these extremely hardworking people in the field, like my students and my collaborators all around the world, because this telescope was actually able to be cooled down to a temperature that's 10 times lower than the temperature of interstellar space, which is just unfathomable. So a quarter of a degree above absolute zero. So if you could cool something down to absolute zero, all of its motion, all of the chemicals, all of the molecules would completely stop dead. And perhaps if there's no motion, there's no time, right? So time is really measured by the reckoning between successive events. Well, if nothing's moving, no time could elapse. And that's deeply connected with this theory of inflation. So how do you go from non-universe to universe? It's kind of a big mystery, right? It's like going from non-life, like just chemicals, pouring chemicals together and getting something living. And so for me to go from non-experiment to experiment, although that's the 0 to 1 moment in Peter Thiel's language, I know you like him, going to that extreme is very difficult, but it's not as hard as getting all the assets together, like a military campaign to the bottom of the world. So that took 4 or 5 years to do. Then by nature of the faintness of the signal, we had to observe for a total of, between the two experiments that I was a part of that made this announcement possible, 6 years of observations, and then another 4 years of data analysis on supercomputers, just running nonstop, the biggest, most massive computers on Earth. And then 50 people working, at sometimes day and night around the clock to make this announcement that we had seen the spark that ignited the very Big Bang that we believe exists today.
So you saw the 6 years of capture were done, then a further 4 years of processing. And at the end of that, what happened? Because someone at some point has come into the room and said something like, Professor Keating, I think we found it. Like that point must have occurred. Can you talk us through that?
Yeah. So that's one of the ironies of the book, and one of the things I think the book does a good job at attempting to describe is how human scientists are. So what you just described is the confirmation of a theory, right? You said I think we found it. So that's like eureka. What does eureka mean when Archimedes would say it? I mean, eureka, I found it. So to find something means you were looking for something, right? Unless you just I saw something, like that's weird. And that happens a lot in science too. And I argue in the book that's the purest form of scientific discovery, when it's serendipitous.
That was like the deep field image, right?
Yeah.
Like there's this big blank space. We're just going to point the thing at it, see what happens.
Yeah, or closer to where you are now, Jocelyn Bell, discovering pulsars for the first time, completely accidentally. She wasn't looking for pulsars. It just showed up in her data, and she did the hard work to unravel it. And eventually a Nobel Prize was awarded for her work, but not to her, to her male advisors, as I point out in the book. But exactly. So there's serendipitous discoveries. Those are pure. Those cannot be found. And they're also not susceptible to what's known as confirmation bias. If you have some idea about me, or, you're bouncing at a club or something, you have to have some notion about, what's desirable or what you're looking for. But in science, we like to think that scientists are completely dispassionate. But what if there are non-scientific forces at work, such as, people like me, who at the time was really obsessed with the Nobel Prize and winning it, and being elevated to this very, very tiny pantheon of scientists who are household names. That was so enticing. It really dominated a lot of my early career mental energy. And so when we did discover the signal that I knew, if correct, even when I came up with the idea for the experiment, would be the biggest, home run, or what do you call it? Century, hitting a century. I don't know. In cricket, the idea of doing that was so intoxicating to both discover the purity of the scientific quest, but also, being honest, to win a Nobel Prize. When we did that, of course, then we just basically, looked in as many places as we could to see if we were right or not. And it kept coming up that we were. But the farther we went down, the more committed to the hypothesis confirmation we were as well. And then the ultimate revelation was done not in a peer-reviewed journal article, as typically required as the gold standard of scientific discovery, but only since the late 1800s, by the way. But nevertheless, that discovery was announced, at a press conference held at Harvard University on March 17th, 2014, to, as I said, worldwide fanfare, with Nobel laureates in the audience, and other Nobel laureates speaking to those potential Nobel laureates, speaking to those past Nobel laureates. And I wasn't at that event. And the feeling of creating something, being a part of something, only to see sort of the control taken away from me, that is a big element of the book. And furthermore, the quest that drives many scientists. I say not all scientists suffer from the same malady that I did, but many of us do. Just listening and the few podcasts that you've done with scientists, and they're fantastic. The word Nobel Prize comes up awful lot, and it's sort of a way of subconsciously perhaps acknowledging this authority bias that human beings have, that we want to have experts to listen to. We want to offload the responsibility of thinking for ourselves. It's just honest. We want to trust that Einstein knew better than us. So he won the Nobel Prize and he came up with the photon and special relativity. So I'm going to listen to him about world government being the ideal situation. And, I don't know how you feel about that. But
people, I think you are totally right. We sometimes afford particular intellectual thinkers an almost universal level of admiration, which, Sir Isaac Newton, there we go, like, fantastic. Like, listen to him about physics, probably don't listen to him about what you should do with your Sunday afternoon. Like,
exactly. Yep. And it's called the halo effect. People want to believe that there'll be people, so in America, every 4 years, we get this list of Nobel laureates that say, which Democrat you should vote. I've never seen them once say they should vote for a Republican. Now, you can say whatever you want about Republicans or Democrats, but if it's scientific, there should have been at least like one who would, it's hard to believe the groupthink is so, but it is, and that's only. Wow,
it totally is. This was the. I'll give you the 30-second synopsis to my podcast with Sabina. For anyone who is listening, if you go back, Sabina Hossenfelder, The Beauty in Physics, I think it was called, the episode. And the bottom line, the punchline of the whole thing was that I had discovered during the podcast that physicists were people too. Yeah. And I always presumed that they were these input, process, output, robotic, kind of paragons of perfect intellectual pureness. And and it turns out that it's just as political, if not more political than so many, it made me feel like my job, which is manipulating social networks to get people to go to nightclubs, almost felt like relatively kind of noble. And then on the flip side, there's all of you got to be in this right camp. You can't be backstabbing this person. Oh, you've adhered yourself to this particular kind of theory. That means you can't be in this. And I couldn't believe just how bipartisan and tripartisan and all the rest of it was. It blew me away.
It really is. And it's a way of just oversimplification, which is a natural human urge. And it just proves, that humans, scientists are human. And I think the cliche, the trope that we're just walking Wikipedias is really nonsensical. And I do my best to, display the humanity of the scientist by both making many, many mistakes every day. You can ask my wife about that. But also, having a real clear cut, kind of image of what is important about science. So if you look at science, the word science in Greek roughly translates into knowledge. But that's very different than wisdom, as I always point out to my colleagues. Just because you're a scientist, it has nothing to say whatsoever about your wisdom. I mean, so one Nobel laureate, he was actually here at UC San Diego, where I am. He said, if you think that Nobel laureates are so brilliant, you should see them in the morning of the event when they're trying to find where the eggs are served. It's just, which is another cliche. But at the same time, again, I don't have problems with the Nobel laureates who win. I have an issue with this process, with this establishment, which, like what Sabina talks about, both of our books have a similarity in that we're taking on these sacred cows, and sacred cows are not always, deserving of that stature. And I think in the case of the Nobel Prize, it's held to such high esteem that one should be careful about the outsized influence that it has on scientists, certainly, but especially on non-scientists, members of the public, members of your audience. When they hear Nobel Prize, they're just going to stop thinking. I'll listen to what and it's mostly men, by the way, which is already a tip off that there's something rotten in Stockholm, right? I mean, there's anyone who thinks that women aren't as bright as men, so why is it true that only, 1% of all winners of the Nobel Prize in physics and chemistry are women? There's something obviously at work that's systemic that needs to be changed. And yet the Nobel institution is incredibly ossified, and really susceptible in my mind to a vast reformation that they're very unwilling to do. And
can you take us through what the Nobel Prize is? Because the term of the Nobel Prize, I know it, and again, I am Mr. Avatar for the lay person. So yeah. I know that the Nobel Prize is given in a number of different categories. I know that it's maybe once every year or once every couple of years, and I know that lots of Jewish people win it. Like those are kind of, that's the beginning and the end of my knowledge. I don't know why it exists. I don't know where it started. I don't know who looks after it. I don't know what the process is or whatever it is. So give us the cliff notes on what the Nobel Prize is.
So my book begins with the story of how Alfred Nobel's younger brother blew himself up. And it's kind of weird. Like, what does that have to do with cosmology? So Alfred Nobel was a Swedish, actually Russian Swedish inventor and entrepreneur, who was the son of a father who had invented some military applications for high explosives in the 1850s in Sweden, and had mainly been selling them to the Russian Empire for their many wars that they were conducting in that time period. But the goal of having a stable form of nitroglycerin, which is very, very powerful explosive, but also very mercurial and explosive, and dangerous. That was a goal of many, many inventors. That would be the killer app that could be used to safely do construction if it could be invented. So Alfred Nobel's younger brother, so he was one of 7 kids, I believe, Alfred, and 3 or 4 of them died before they were 22 years old, mostly by natural causes. But in the case of his younger brother, he was experimenting with this compound, nitroglycerin, and he dropped a vial of it, and it blew up the laboratory in Stockholm where he was working, and the family laboratory killed about 4 other people that were his lab assistants. And that really drove Emmanuel Nobel, the Nobel brothers' father, insane. And he ended up giving control of the company to one of his other brothers. And one thing led to another, but Alfred went off on this quest, single-minded focus to find a safe version of nitroglycerin. And he invented it, and it made him perhaps one of the richest people of the world at that time. In today's dollars worth, billions of dollars. And this company that still bears his name exists, which is amazing. There are very few companies, that are based on an invention by an inventor from the 19th century that still have that name, that still exists. I mean, maybe 10 of them around the world. In this case, it made him incredibly wealthy, but it was still tied to the manufacture and sales of arms between different countries in Europe that were continually at war with one another, and then also dynamite and balisite and all sorts of other military cordite explosives used to kill people. And one day, about 20 years after he invented dynamite, Alfred was walking around the streets of Paris, France, and he came upon a headline that said, "Alfred Nobel, the merchant of death, is dead. And the man who had killed more people in history than any other person has met his own just reward." They were kind of gleefully celebrating his death. And it was very shocking to him. It must have felt like, Ebenezer Scrooge or, somebody like really celebrating their death. And it shocked him so much that he resolved to use his vast personal fortune after he died to endow a will, which would give out prizes in 5 categories: literature, medicine, physics, chemistry, and peace. And so peace kind of the one that a little bit stands out. But all 5 of these awards, and they've since enlarged it to include economics about 80 years after he died, and they're given out annually. And what Alfred wanted, and he said explicitly in his will, which you can find on the Nobel Prize website to this day, he said, "I want these prizes to go to the person," in the singular, "who created the most important or beneficial discovery or invention in the preceding year that has had the biggest benefit on mankind." So there are 3 stipulations. A single person would win it for an invention made last year and that had the greatest benefit on mankind. Now, unless you're a theoretical particle physicist, I don't know how much the Higgs boson improves your daily life or benefits your daily life. If you do, then, please consult a psychiatrist. But because, it's really not that relevant to our daily lives. It's very important in the grand scheme of the universe, but it would exist whether we discovered it or not. Unlike, say, the X-ray, which was the subject of the first Nobel Prize in 1901, which has improved and bettered the lives of human beings.
Is that what got the first Nobel Prize?
Yeah, so I talk about that.
That's a pretty cool, pretty sort of big impact discovery, right?
Absolutely. And there have been other ones. And so I point out in the book, because what happened was, as I said, Chris, I was, created this experiment, which was immediately claimed to be Nobel worthy the day of the announcement in 2014.
Which you weren't there for.
What's that?
Which you weren't there for. You weren't there for
I
the
wasn't
announcement.
there for. Yeah. So I talk about that very best. I'm very honest in the book about, my foibles and faults in the whole affair. But in truth, I think it ended up being that there were competitions and there were discussions and polls on the internet and papers published, that really claimed that of all the, kind of people on Earth, that I might have a decent shot, better than 1 in 5 or something of winning a Nobel Prize, which is pretty high. There's, billions of people on Earth, right? And how often do you get to be in that very select group? Mm-hmm. And then, as I describe in the book, it was not to be. Obviously, the title would be different if I had won the Nobel Prize, not lost it. So the title of losing the Nobel Prize, but it has two different meanings. One of the meanings is how I personally lost it and lost out on this opportunity, although creating something Nobel worthy and then having that slip away. I describe the emotions of that and the personal side of that, but also the cosmic side of it. What does it mean to talk about things like the multiverse and like the inflationary universe and the creation of the Big Bang? What does that mean in a world, in a universe that's polluted with contamination and with confirmation bias and with all these other foibles that human beings have? So that's one aspect of the title. But then if you can imagine this, so imagine, Prince Harry, he and Princess Meghan, they want to come to a club and you're at that club and they're about to come into your club and you hooked it up. They're just so, you're just going to love it. You're going to take selfies with it. And then right before they get there, they say, you know what? We're not going to come to your club or any of your clubs. In fact, could you recommend a better club for us to go to, better than any of the ones here? So what ended up happening was not only did I lose the Nobel Prize chance that I, best chance I would ever have, but that same year that I potentially could have won it, I was asked by the Swedish Royal Academy of Sciences to nominate the winners of the Nobel Prize that, I would have won had my experiment not been disconfirmed and our results retracted.
Wow.
Our claim of discovery retracted. The experiment was correct. It still is correct. We still believe it's true, but the interpretation of what we saw has been changed radically from detecting the imprimatur of God, if you like, or of the Big Bang, of nature, to the most humble substance in the universe, this cosmic dust that I describe at some length in the book.
I was going to say, what's the specifics about, because you've gone from, you were there, you were at the finish line, ready to go, but it seems like there's kind of two elements to this story. One of them is the potentially systemic, more political, the side that I want to hear a little bit more about, how the Nobel Prize is judged and stuff like that. But obviously the sort of meat and veg of it is the fact that what you found was interpreted differently to what you originally thought. Is that correct? Can you take us through that?
Yeah. So when we set out to measure the universe's earliest light and this curling, twisting pattern that gives Bicep its name, etc., the experiment was designed to see an effect. In other words, it was designed to see this leftover aftershock of the Big Bang via gravitational waves. And so it wasn't designed to necessarily rule out every other potential source of cosmic mimicry. So there could be sources that we did know about. Say the Earth emits a type of signal that could be mistaken for it. So we designed the experiment to block out the signal from the Earth because we had to locate it at the South Pole on Earth. Similarly, say the atmosphere could do it, or there could be emission from sources that are not cosmological, but they are in the solar system or in the galaxy. And we knew about those sources and we did our best to eliminate them. But there was one source that we simply did not have enough information. And there was one group of astronomers that had this information. In fact, they were led from the European Space Agency. It was a satellite called the Planck satellite. And they had measured the sky, and we knew that they had information which could tell us if we had seen cosmic dust, which are particles, grains of carbon, nickel, iron, particles left over from a previous explosion of a generation of stars called a supernova that may have existed, that did exist in our galaxy prior to our solar system's existence and other solar systems' existence. And without such supernovae, we would probably not exist, because the iron in your blood, the hemoglobin molecule that carries iron atoms, that was forged. Those iron molecules were forged in the core of a supernova that exploded in our local stellar neighborhood 4.9 billion years ago. So you literally, as Carl Sagan used to say, have stardust flowing through your blood, very poetically, but it also flows through the galaxy. And because it's made of iron, just like the filings, as Michael Faraday showed and others showed, they align themselves in magnetic fields. Or our Milky Way galaxy has a magnetic field too, and it can produce the exact same curling, twisting pattern of microwaves as the Big Bang's inflationary epoch could. So that was the signal that we mistook. And the reason that we didn't have access to information which would have disconfirmed our claim earlier is because it was held by our competitors. The Planck satellite did not want to share this information with us. We didn't know if they had detected it as well as we had and wanted to scoop us out of this discovery and potentially win their own Nobel Prize, or they didn't have a good understanding yet of their own deficiencies, so forth, with their instrument. And it turned out to probably be a little of both. But there's this incredible competition that exists within science to get there, not only get there first, but to just obliterate the competition, like leave no doubt that you made this definitive measurement. We wanted that to be clear throughout the entire paper, press conference, everything we did, that there should be no doubt that what we discovered was what we claimed. And in the end, the results were correct, but we made a very exquisite measurement of the emission from dust particles in our local galactic neighborhood. Incredibly challenging, by the way, because the signals that we saw were just a few parts in a billion out of the temperature of the South Pole. It's just exquisite technology. I describe how exciting it is, this technology, and how it's progressing and will progress based on the lessons learned from BICEP 2 to build a next generation of instrumentation, and such as the Simons Observatory, which is a big project that I am leading here in San Diego, based with institutions around the world. Literally 250 researchers on every continent, currently on the planet, which is amazing to think about. So the real discovery and its aftermath and how it affected me and the field personally is really tied up in this quest, at least personally for me, with the Nobel Prize. And I came to see it, in a sense, as almost a false idol. And I came to see the Nobel Prize, in a sense, as a religion, as a type of religion, ironically practiced by mostly secular scientists, right? 70% of our National Academy of Sciences declare themselves to be atheists, not agnostic, but atheists. And yet if you go to any website, that supports science, or any discovery where, the upper echelons of authority need to be referenced. And even in Sabina's book, and she's not, really beholden to but she, constantly is interviewing Nobel laureates and talking about things that were awarded with the Nobel Prize and saying, well, nothing's been awarded the Nobel Prize. And, in theoretical physics shows you how poor these predictions as a scorecard, as a talisman, as an icon. And I make these parallels between a religion and the Nobel Prize. And I think, they're quite, I think that nobody really disputes it, which is kind of interesting to me. Nobody disagrees with the Reformation. So I present 5 ways to improve the Nobel Prize before it's too late. Because I think if you have an institution that refuses to change its operating, mode, that it's at risk of catastrophic, kind of existential crisis.
Well, it loses its purity, right? Like the whole point, again, for me, as someone who doesn't know what he's talking about, the one of the only things that I want the Nobel Prize to do is for it to go to the right person.
Yeah.
Do you know? So
or people, right? Or people.
I want to get on to what the process for the Nobel Prize consists of, but just the final thing that I want to kind of round off the story for you personally was, how did you find out about the fact that there had been this particular change in how your discovery had been viewed? And then what were the next couple of days like? I'm fascinated to hear what that means to someone who's pushed so hard and come so close.
Yeah. It was a mixture of emotions. First, obviously embarrassment, a little personal sense of humiliation that, I had kind of gone along with this result, even though I had some doubts about it, as we all had doubts, but but certainly I had voiced a lot of doubts and, a little bit of gratitude that, I'd not been, so publicly associated with the face of this detection because I had been kind of eliminated, which I described in the book, and how this role, I wasn't eliminated completely, obviously, but the way the announcement was made, I was, prevented from being a part of it.
So bizarrely, the thing that you felt a little bit maybe jilted at, you'd kind of been left at the altar, so to speak, when it came to the glory, but in a roundabout fashion that had also protected you from being the figurehead who, upon whose shoulders most of the backlash had landed, I suppose.
That's right. Exactly right. And yeah, so, I just admit that, how it felt. I wasn't, glad. I wanted us to be right. I wanted us to be right, even if I didn't win the Nobel Prize. But, in the end, the denouement of the story for me became a recognition that, as I said, ironically, all these scientists are atheists, but they worship this golden crucifix of an icon, the Nobel Prize, which literally has a graven image, a picture of Alfred Nobel on it, and you bow down to it on the day he died in December 10th, December 10th, 1896. That's what the day that they're awarded, not on his birthday. And for me, this kind of religion no longer holds the idolatrous transfixion that it had once before, and that it no longer really consumes my daily life in any way, other than to think that the privilege of getting paid to do the research that I get to do and work with the genius people, students, and other scientists around the world that I get to work with, that is reward enough. And when we make the Nobel Prize this paragon of scientific excellence, we are kind of reducing ourselves, sorry to say, to kind of like entertainers in the Hollywood Oscars.
Oh, it becomes like Pop Idol or X Factor, right?
Yeah, exactly. And for us, I think, scientists should be the most immune from that, right? Aren't we supposed to be hyper rational and these paragons of intellectual honesty? But I think, we're human beings. And the problem is that, as I often say, I did an interview with Scott Eastwood, who's, Clint Eastwood's son, a very famous podcaster here in the States. And, I was saying, like, well, you don't really expect, a movie studio doesn't really expect that all of its films are going to win Academy Awards. I mean, some of them, are going to be like the Fast and the Furious, and they're just not. And he's like, I was in the Fast and the Furious. that was a highlight of my podcasting career. But he agreed with me. It's like the actors and actresses who go into Hollywood, they don't go into it saying, oh, I'm only a good actor if I win a Nobel Prize. Or an Oscar rather. Yeah. But the studios, you better believe they want most of their pictures to get. That's why they have 10 different
Golden
awards.
Globe nomination and this, that, and the other. Yeah.
Palme d'Or, right? All these things, Sundance, and they're all about giving each other awards. And there is no Golden Globes or SAG comparison. Second runner-up for the Nobel Prize. There's just nothing like that. So it puts the Nobel Prize under great scrutiny and holds it up to this level of really austere, of being, just the augustness of winning it. I think that it has a detrimental effect on scientists, but to the extent it's going to survive, I wanted to preserve the purity of it by making certain reformations. I talk about, as I say, 5 of the ways that you could do it.
What are those?
After I've been invited to nominate winners of the Nobel Prize and coming upon it, as a scholar would. So I received a letter a couple of weeks after we made, the final nail in the coffin for our detection back in 2014, and I got a letter from the Royal Swedish Academy which said, do not talk, strictly confidential. So I guarantee it's the last time I'll be asked to nominate winners of the Nobel. But it said, here's what you need to do: look for the multiple winners, who deserve the prize. It could be something done decades earlier, and it didn't mention anything about having a benefit on mankind. I said, Alfred only said 3 things in his will. It has to go to one person in the preceding year who had the greatest benefit. And here they are asking me to do nothing of what he asked me to do. And I felt like, well, that's kind of one of the worst things you could do is not have respect for the wishes of a dead man, right? A dead man has one chance, one will. And imagine, you're going to live, 100 more years or whatever, but you write your will someday and you say, I want all the money to go to Oxfam or whatever. And they give it to whatever. I don't even know what they would give it to. But they give it, or Greenpeace, and they give it to ExxonMobil or BP, you'd be pretty pissed off. But what could you do? Nothing, absolutely nothing, because you're dead. And so I felt like it's incumbent upon scientists like me to advocate for change from within. And I don't have any, delusion that they're going to listen to me. But I felt the story was too important to ignore. And so far, I've gotten great feedback from people around the world, scientists and lay people, about what it's like to really aspire to this and to really make great, important discoveries, but not judge yourself on whether or not this, 3-inch diameter gold, medallion like a rap star would wear, goes around your neck.
I could see you. I could have seen you with that wrapped around your neck, which is a shame. But there's a couple of things I've been thinking about as you've been speaking now. One of them, the first thing that you said was that the humiliation maybe came a little bit higher than the disappointment. And some listeners of the show will know that I came off a motorbike in Bali a couple of years ago. And as I'm driving along, driving a 50 pence per day Balinese moped, which is that was my first error. The second error is not really being very good at riding a motorbike. And a truck pulls out in front of me, and I come off the bike anyway, and I'm wearing a tiny pair of swim shorts and a little vest. And it's me versus Balinese road, and it wins all day. Like, I've got kind of like 2nd-degree burns on half of my body, and most of the left-hand side of me is stuck in the Balinese tarmac, which is very coarse. It's perfect for removing skin. It'd be a brilliant cheese grater. And the first thing that I felt, so I was riding with these two Aussie guys who I'd made friends with while I was out there. I was traveling on my own. I'd made friends with these two Aussie guys, and they kind of knew me, and I kind of knew them beforehand. But anyway, we were relatively new friends. And I was in mortal danger. I'd just injured myself. Like, the forefront of my mind should have been my injury. And the first thing that I felt when I stood myself up and brushed bits of tarmac out of me was embarrassment. Ahead of Abraham Maslow's hierarchy of needs, like, forget the fact about, like, I'm worried about I'm injured, or is this going to scar, or, is another car coming? Is there going to be another car behind me that hits me? No. I wanted to stand up and think, oh, you twat. Like, that's the first thing that I thought. And it's just so telling of the fact that we are, no matter how, as you say, these sort of paragons of beautiful intellectual truth and purity and all the rest of this stuff, it's born out of a flawed system, and that system is human. And the other thing is that I think is really super interesting is the journey that it's allowed you to go on, which I think is a lot of people will be able to draw a comparison with, which is kind of that of discovering that the process of what you have created, that life is a process of becoming, not being. And that as you've gone along the way, you're now able to look back on it and say, well, like the fact that I was able to bring all of these people together, and in a very bizarre way, I wonder whether or not you would have the same level of nuanced and subtle appreciation for all of the different elements if it was overshadowed by a large award. I don't know whether you'd be able to look back with the same degree of high fidelity, that granular kind of...
Yeah, absolutely. No, I agree with you 100%. I mean, I always joke, if people say, oh, you're a hypocrite, you wouldn't turn a Nobel Prize down if you want. I say, well, if you want to see if I'm sincere, just get them to award me the Nobel Prize. And if I don't reject it. But in all seriousness, I feel like... yeah, it's almost a blessing, because it's sort of like a liberation. I don't know if you're married or whatever, but I always say, when I met my wife, I got to stop like going on dates. Like, I never have to have a first date again, hopefully.
Yeah, I get that.
And it's very liberating when you free your mind of it. And so when I freed my mind of obsession I was told to get tenure, to get to high level of promotion at the University of California, I have to win a Nobel Prize. I've been told by many people that they're basically judged in their careers on their prospects of winning a Nobel Prize. To be liberated from that and say, like, well, that is completely an asinine metric by which to judge a human being. And I say in the book, the journey is more important than the gilded destination. And, we make fun of, like, I don't know if whatever, how biblical you want to get, but, back in the Bible, it talks about the Israelites worshiping a golden calf, this icon made of gold that they made themselves, a few weeks after witnessing God allegedly, wipe out Egypt with all these plagues, right? And I thought, well, that's so silly, but in truth, 3,000 years later, here we are doing the exact same thing. We worship a golden icon with a picture of Alfred Nobel, and that is part of the way that we value our self-worth. I think that that's a shame in a modern scientific society to feel that way. And so I feel like it's part of my, one of the lessons learned and how to handle it. It's not just about, losing a Nobel Prize, which, probably all of your listeners can sympathize with, but how do you handle not winning, top 50 podcasts, or how do you handle not getting to, be high school class president? These are all things that, you're far more likely not to get into your own personal promised land than to get in it. And that's okay, right? You're not going to get in to be Manchester United or Newcastle. What is your team? Newcastle, whatever. So, from my perspective, so how do you handle that? Because that's the state. If you look at the probability distribution of what you're going to spend your life being, it's not being a Nobel Prize winner. It's not being.
It's as Pareto as it comes, isn't it? It's
exactly
one or done.
Exactly. So I hope that people, will enjoy the journey and not fixate on the destination. Let's hope the journey is a lot more successful than your Balinese motorcycle journey, though.
Yeah, that would be nice. I think it's super, super interesting to speak to yourself, especially after having spoken to Sabina, and to hear just how folly some of the elements of science are. And something that was super interesting that we kind of moved past was when you had the European Space Agency and they didn't supply you with the particular types of information that you needed that would have helped you further your research. And you think I think from my side, things like physics, especially when we're talking about making developments and learning about the universe, is the same as medicine in that the goal should be as wide and as vast progression as expedited as is possible. But that's not what happens. It becomes narrow and deep because there's certain information that will benefit one particular group and over another, and et cetera, et cetera. And I don't know. I think removing ego from the situation is going to be impossible, and you can't litigate for it. You're not going to be able to have someone come in and say, oh, you need to share your research with these people or whatever. And as well, we can talk all we want, and the listeners will be in the midst, once we are broadcast, you'll be in the midst of some very mindful other guests that we've had, Rick Hansen and Corey Allen and all these meditation experts, detached from the ego and all this sort of stuff. But on the flip side, telling someone who's won something fantastic, yo, man, you should have never even gone for that in the first place. You should detach from your ego. You're like, well, no, fuck off. I worked really, really hard for this, and I'm the one that got it. And because that story's newsworthy and all the ones of the runners-up aren't, you inevitably end up with this asymmetry of glorification.
Yeah, but exactly who is going to advocate for reform, right? There are people that, when it have a vested interest in it. I note that there have been peacemakers who turned down the Nobel Peace Prize, right?
Oh yeah, I wanted to ask that. What do you make a Peace Prize? How does that work? What do you have to do? I mean,
some of it's been, it's one of the few prizes that anybody can nominate anybody for. So you could nominate me, I could nominate you.
Let's do that.
Whereas we can have a fontaine. Yeah, but the physics prize, you have to be invited. Right. And one of the criterion to be invited is that you won a Nobel Prize. That's one option. So the rich get richer. If you won a Nobel Prize, your graduate student and postdoc is much more likely to get a Nobel Prize. Or conversely, if you work for somebody, you're likely to get. So I go through all these kind of different machinations within it. But, I think there is sort of a vested interest in keeping. Look, the Nobel Prize is a monopoly. It's the most prestigious award of its kind. Just like the Oscars are a monopoly. Yeah, there are other runners up, but it's pretty head and shoulders above them, right? But the Nobel Prize, there is no real secondary competitor to it. I mean, I challenge, people to know about it. And so as such, it has a huge responsibility to inform the public about how science is actually done. I describe in the book some of the cruel aspects of the Nobel Prize, wherein, people that, mostly women, but sometimes men as well, including just 2 years ago when one of, Scotland's greatest scientists, Ron Drever, was basically written out of history because he happened to die, 6 months before the Nobel Prize for LIGO was awarded. And it's all part of these crazy rules that they like to adhere to, that they themselves choose and pick what to apply. As I say, they don't follow what Alfred wanted. So I hope your listeners get a chance to engage with it. We have a couple of websites we set up. One is just called losingthenobelprize.com, where people can suggest winners and put a petition, kind of like the moveon.org strategy. And then I have a mailing list on my website, briankeating.com, that people can engage with. I love hearing from people, how it's affected them, and it's gotten a lot of good attention. I used to think, well, I shouldn't even care about like whether it wins these awards for best books of the year. But
you just getting drawn straight back in again.
I did. I'm like, I can't even be stoic anymore. It's like I'm too fortunate. No, it's received a lot of lovely attention. And so, yeah, I'm really interested to hear what you think about it. And
I'm excited to read it, man. I really am. I think the minutiae, and I'm looking forward to finding out the sordid details about what goes on behind the scenes and stuff like that. So, yeah, Brian, man, it's been a blast. Thank you so much for coming on. I really appreciate your time.
Thank you so much. And let's keep in touch, Chris.
I certainly will do. Links to everything will be in the show notes below. Please make sure that you follow Brian online. He has a very interesting Twitter feed, and his website will be linked below. So, man, thank you. Catch you later on.
Thank you so much, Chris.
Bye-bye.